User verification is an important part of user sign-up flow. One common way to do it: use email verification when we send to a user an email with a special link to confirm that email address is real and belongs to the user. In this video, I'll show examples of email verification with Node.js and Mailgun API. Additionally, I'll talk about the abstract factory and adapter patterns and share my tricks for determining when it's best to move some code into a separate class to follow the separation of concerns and inversion of control principles. We won't consider this case very close from front-end perspective. We just have a sign-up link and a minimal form where all fields are required. And the most important field for us is user email. This email we will use for user verification. When the user filled all the fields and pressed sign up, we send the payload to the server endpoint. We suppose that the sign-up request was successful and the user was created in the database. And now we need to send a verification email to the user to confirm a new account. So we move directly to email verification service that prepares and sends verification email. This service has one method that is keeping the entire logic of creating verification email. It also has two private properties, adapter and factory. We will need the factory instance to generate content of email. And we will use the adapter instance to interact with third-party mailing API. In my case, with Mailgun API service. Let's look at what happens in the send verification email method. Before generate email, first we need to create and save a token. This token will be used as a parameter of the verification link which we send in email. If we go to the generate function, we can see that the token is simply a random value. You can use a different format and size for it, but the main idea is that it's a unique and secret value that is associated with a particular user account. I store the token in the database as an object of type verification token model, which in addition to the unique value itself contains the user ID and creation date. So when a user clicks on this link and goes to the email verify endpoint, we will be 100% sure which account needs to be activated. This is a big picture of the user email verification flow. After we have the token ready, we need to prepare common email parameters like subject, from, and to. The subject is just a string constant of the email verification service class. I'm getting the username from the user object for to parameter because in my case the username is a user email. And for the from, I use the environment variable email domain. After that we need to build a body of email. We can't just put all the HTML code right here inside the send verification email method. But from my view, creation of the email body is a more specific and low-level thing that is better to move into a separate class. We can say that I prefer to follow the separation of concerns principle here. To produce the HTML string, I'm using the factory instance. That is property of the verification service that we passed into the service constructor during initialization. It will give us an opportunity to use different realizations of mail factory that implements the same interface. And here we have another fundamental principle of software development: inversion of control. In fact, the mail factory is a dependency of service class, and we have here dependency injection pattern. This is a more specific case of inversion of control. I use separation of concerns and inversion of control here, mostly based on my intuition and experience. But I can give you a couple of clues to help understand when you will need to go this way. If you have suspicion that some code can be moved to a separate class, as in my example with email generating code, just ask yourself if it is possible that you will have other tightly related logic that can be encapsulated in the same separate class. And if you think so, that can be a solid reason to create a new class. For my project it could be restore a password email and notification email methods that with a high chance I will need in future. This is why I think here is a good place to follow the separation of concerns principle and create a special class for email generation purposes. Another question that you need to ask yourself: is it possible that we will need other implementations of the verification email method here? And I can imagine that someday a marketing team will want to send out stylized emails for Christmas or Halloween parties. So this is why we need a family of interchangeable classes to implement variation of logic. An instance of one of them will be injected as dependency to the service via constructor. we determine an instance of which class will be injected on the level of service initialization. When the service calls the mail factory instance method, we can say that the control flow is inverted to the upper level of application, to the place where the service was initialized, and where the decision of what practical implementation of factory to use was made. This is the inversion of control principle in action. To implement everything I mentioned above, I used abstract factory pattern. Abstract factory is a creational design pattern that lets you produce families of related objects, so-called products, and encapsulates the logic for creating each family of products into separate classes, so-called concrete factories. Concrete factories extend the abstract factory interface and are interchangeable. The first thing the abstract factory pattern suggests is to explicitly declare interfaces for each distinct product of the product family. In my case, I have a much more simple situation, because my products are just mail body contents that always are strings. But from a semantic point of view, verification, restore, and notification emails are still different products. The next thing is the abstract factory interface that declares a list of creation methods. This is how the abstract mail factory interface looks in my code. Here you see 3 method signatures that each product in the email family produces: confirmation, recovery, and notification emails. For each product family, we will have a separate concrete mail factory that will implement abstract mail factory interface. Simple mail factory, Halloween mail factory, and Christmas mail factory all implement abstract mail factory interface. I prefer to keep them in a separate folder called factories, and use the index file for initialization and expose instances according to my common project structure concept. The last important rectangle on this pattern scheme is a client, and in my case the client code that uses the email factory instance is the send verification method of the email verification service class. As I showed before, the client service gets a concrete factory instance via dependency injection during the initialization stage. This is a higher level of application which is out of bounds of current scheme, so we can open the code to look how it happens. In my code, initialization of email verification service happens in the index file. Here I'm using an if-else statement to select an appropriate factory depending on date. And at this point I inject it into my service instance, which will be available for use by the application. When the body is ready, we will have everything to send the email. We can call the Mailgun API directly in this point. But I think it will be more interesting to introduce another design pattern here that allows us to not depend on a single API. This way we make code more extensible and the solution more general. As you can see, I am using an adapter property that is injected into the service during the initialization phase, just like a factory property. From the name adapter, you can guess that we are talking about an adapter pattern. This pattern will give us a common way to work with different API clients. Adapter is a software design pattern that allows the interface of an existing class to be used as another interface. In other words, it allows objects with incompatible interfaces to collaborate. In my case, the client is the email verification service that calls the send methods on the adapter. The client interface is some kind of expectation of client code that the adapter must meet. In my project, the mail adapter interface is pretty simple. It has only one method: send email. So this is only one method that all adapters have to implement. The adapter has an adaptee property that contains a service object. This service will be doing a real job for sending email. The idea of adapter is to wrap the service and translates calls from client to service in format that service can understand. In the Mailgun adapter code, I prefer to use the name provider for the service holder property instead of adaptee as it was in the scheme, because in the context of the task we speak about providers of third-party mail services. The adapter receives the provider at the initialization stage through the constructor. In the send-email method, it uses a provider interface to perform mail sending via API. Both adapter instances are initialized and exported from the index file. Here is the Mailgun provider class. It looks very simple. I just use Mailgun.js library to create the API client instance. I call it Mailgun provider. This is a provider instance that is going into Mailgun adapter. To create the instance of Mailgun client, I pass two parameters: username API and my secret API key that I keep separately and take from global process environment variables. Mailgun.js is an npm package that makes it easy to interact with the Mailgun API. You need to add this package to your dependencies. The structure of the providers folder mirrors the adapters folder. I have a Mailgun and SendGrid provider with an index file. In the index file of the email service folder, one of the adapters is selected based on the Mail API environment variable. And in this line, selected adapter is injected into email verification service. To use Mailgun service, you need to create an account and get the API key. By default, Mailgun suggests you to use a sandbox domain to test your messaging, and I'm using it now in my example. Recipients will see this domain in the From field, and for production you will need to use your project's actual domain. Also keep in mind that if you are using the free plan, you will only be allowed to send emails to recipients who are added to your verified list for that domain. To get the key, you need to go to API Keys panel, press Add New Key and copy it. The key will show only once. Basically, this is all that you need to do. Now you can use this key in your app. To use my real domain, it has to be verified by Mailgun service. To prove that domain is yours, you need to follow this instruction and add several DNS records related to your domain. Values for these records you can get on this page. I added all 5 of these DNS records through my hosting provider's control panel. This may look different depending on your provider, but the idea is the same. Once you add these records, it will take some time to complete verification of the domain. For me it took 5 hours, but could be up to 24. When the domain is verified, I can use it to send emails. So I put it in environment variables instead of the sandbox domain. Now that we know how emails are created and sent, let's go through the registration process and check the email in my inbox. In the From field, you can see my verified domain. The text of the email is quite simple, and the main thing here is a verification link. This link directs the user to the verification endpoint, where the account verification logic occurs. I followed this link and got this API response. I successfully verified my account. Let's take a look what happens at the verification endpoint. Here is email confirmation logic. We take the token ID from the request and use it to retrieve the token object from the database. This is what the token class looks like. It has a user ID property, so we can associate it with the user account that needs to be verified. Here we can handle some situations where the token is missing or has expired, but I've skipped those for now. In this line we take the user object by ID, then set its verified parameter to true and save the object. And now the account is confirmed and I can log in. In this video we considered the concept of user account verification with email using Mailgun API. To make the example more interesting and valuable, I showed the use of abstract factories and adapter patterns. I also touched on some fundamental principles of software development: separation of concerns and inversion of control with dependency injection. I hope this helps you not only apply email verifications in your projects, but also gain a deeper understanding of software design best practice. Another very important pattern that I especially ask you to use when watching my videos is the LSBC pattern. Like, subscribe, bell, comments.